All right, welcome to the second session for the Mach 3D tutorial. I'd like to thank you all for joining me. So today, we're going to cover some different content than last time. We're going to take a look at dam templates to start. It's just a fast, streamlined way to create dam shells, create discharge lines while you're creating the dam shells. Probably an underutilized feature in the software. Then from there, take a look at the surface water tools. I see people are filing in, so I'll just admit them. Yeah, take a look at the surface water tools in terms of generating stream networks, catchment areas, and then take a look at more of those dynamic structure modeling tools that we did cover last time. This time, look at excavations, ditching, and some dynamic modeling with road structures. Then from there, talk about multi-stream deposition. And hopefully we can fit that all in the next hour and a half. Okay, so to begin, I'm going to start in Catapult. And I'm going to utilize another demo project here. Okay, so I'm just in Catapult here. And once again, I'm going to utilize some demo data that comes. Maybe, you know what? Maybe I'll give it a couple more minutes and let everybody arrive before I begin. Okay, so if you have any questions, you can put them in the chat. If I don't get to it, my colleague and then manager Carlo Cooper is here on the chat. He's made the software, so he'll definitely be able to answer your questions. So to begin, if you guys could just open Catapult, we're going to utilize some demo data here. Okay, so I'm going to, this time, utilize the Pine River Hills demo data. So if you open Catapult here, at the top, you have a create demo project. We're going to go ahead and utilize the Pine River Hills demo data. If you've already started a project from that Pine River Hills demo data, like I have several times, just make sure you call it something unique so that it actually creates a new project folder for you. I'm just going to add the date here to the project name so that it creates a new project directory. I'm going to hit OK. Select my license. I'll wait for it to load. Okay, so I'll give you guys a couple seconds to make sure you're booted up here. Okay, so you'll notice here in the Project Explorer, under that base folder, which is preset to be your working directory, to begin, you have some lidar_survey.xyz data. Okay, so this is lidar survey data, point files of some topography. So first thing we're going to do is we're going to take that lidar point data, turn it into a surface, and then turn it into a grid, and use that grid as our topographic base to work off of. So I'm just going to take this lidar survey XYZ data and just directly drag and drop it into my 3D window. So it loaded pretty quickly. If I zoom in here, just using my mouse wheel, I can see, there is point data here. I'm use the left mouse button to tilt this a little bit, zoom in again. So you can see the makings here of some topography. I'm going to hit R and go back to plan view, zoom out mode. Okay, so first thing I want to do, I want to create a surface. So I'm going to tin all these points into one comprehensive surface. Surface, create, surface from layer. Shortcut button here. Also be found in my toolbar right there, surface from layer. So I've just loaded my LiDAR survey XYZ data from my Pine River Hills demo project. So just to recap quickly, I've gone here in Catapult, created a demo project. I've chosen Pine River Hills this time, loaded it up, and that contains this LiDAR survey.xyz file that I've just dragged and dropped into my 3D window, and I've loaded up this point data, and I'm going to use that point data to create a surface. Okay, so I'm hitting this surface from layer shortcut button here, which can also be found under surface, create, surface from layer. I'm going to call this PRH, Pine River Hills underscore surface. I'm going to hit OK. Okay, we'll notice here in the scene manager, that new layer has been created. It's currently unsaved, and that's why it is red and bold. It's not visible because it's being obstructed by my point data. I'm just going to close this layer or unload it by right-clicking on it and hitting unload this. And you can see here, the surface reveals itself. I do want to save this, so I'm going to go ahead, right-click, and save it. And right now, I'm just saving things to my working directory, which is the base folder. Okay, so once again here, I can see my surface. Use that wheel mouse, or that mouse wheel to zoom in and out. Left mouse button to tilt, right mouse button to pan. If you want to see the makeup or the wireframe of the topographic surface, just hit W on your keyboard, and then S to go back to a comprehensive smooth surface. Okay, somebody's just arrived, so I'm going to quickly recap again. So we're working with demo project data. It can be found in Catapult here. If, prior to launching the software, just go to Catapult, go to Create Demo Project, hit that drop down, and I'm currently working with Pine River Hills. So just load up that project, and then you'll see here you have some LiDAR survey XYZ data. You can just drag and drop that into your 3D window. It'll look like this, and then go to Surface, Create, Surface from Layer, and that'll create a topographic surface from this LiDAR XYZ data, and that'll look like this. I'm just going to unload that survey data right now. I don't need it. I have my surface. Okay, next, Muck likes to work with grids. So if I want to do design work, I want to build dams, roads, excavations, I want to pour tailings, it needs to be on a grid. The difference between a grid and a surface is the surface is just all that LiDAR data triangulated together. The spacing of it is fairly random. With a grid, it takes this surface and then it resamples the data, places a point at evenly distributed spacing, and then creates a mesh in a evenly distributed pattern, which is a lot more efficient for the software to use. Very simple to create a grid from a surface. Just go to Grid, Create Grid from Surface. Select my surface. Okay, now here it's asking you what spacing would you like on your grid? How sparse do you want the mesh to be? It's giving you the number of points that are going to result on that grid based on your spacing. So everybody wants, the tightest grid possible, the most dense data. If I do a 1 meter grid spacing here, I'm going to have 30 million points. That's not going to work. Even at a 5 meter grid spacing, 1.2 million points, that'll slow things down, particularly for, the purpose of this session. I'm going to go with a 10 meter grid spacing and, work with a topographic layout that has about 300,000 points. And I'm going to call this grid 10 meter, just so I know it has a 10 meter grid spacing. Okay, once again, it's create a new layer, red and bold in my scene manager. So currently unsaved. You're going to want to save that. Once again, I'm going to put it into my base working directory. And then I don't need my surface anymore. I'll be working with this grid. So I'm going to unload the surface. Okay, so first thing we're going to take a look at are dam templates. So a dam template allows us to define a generic or a preset, dam design, crest width, upstream slope, downstream slope. Refer that design to a reference line. So there's a question in the chat. Okay, good question. There is a plan for future to allow to import larger files. So in this version of Muck 3D, I guess you are more limited in terms of the size of the topographic surface data that you can use. In this upcoming version right here that I just loaded up, which is going to be released shortly, you can handle much larger files, much larger topographic surfaces. So this is V 2025. It will be out soon. In V 2023, you are a little more limited, but that's gonna change very shortly. And for future sessions, we'll probably be using the updated version as it gets released. Okay, so first thing we're going to do is we're going to take a look at dam templates. So I'm going to begin by going to the dam template menu. I'm going to go to Setup, and I'm going to hit this Dam Profile Manager. I'm going to start by defining a centerline template that I want to use, which is a generic design that I want to apply to a center line in the future to allow me to build dam shells quickly without having to, offset line work to different elevations. Okay, so I'm going to go to this fixed width center line. And I'm going to define a template here. Right click on this, hit new. I'm going to call it CL for center line. I'm going to use a 4:1 downstream slope. I want my dam to have a 3:1 upstream slope. I want a 50 meter crest width. Here, the skirt height is the height of the unclipped dam shell that I'm going to construct. So this is the distance that we're going to be projecting down from the crest to the toe for the shell, just the shell that we're going to create. So you just want to make sure this is long enough. So I'm going to go 100 meters. And I'm not going to put any cutback slopes at this stage for this example. So I'm just going to leave these both at 0. Then I'm going to hit OK. So I've just defined a generic dam design here for a centerline dam. 4:1 downstream slope, 3:1 upstream slope, 50 meter crest width, and the unclipped shell is just going to be 100 meters. So it's going to take that crest elevation and go down 100 meters to make sure I go through topography. I'm going to hit OK, and I'm going to save. The next thing I'm going to do is I'm going to pick a location to build these dams based on that design. So for that, because I've decided to, define a centerline dam, I need to locate the center line. So I'm just going to draw a dam quickly and then use that center line for my template. So I'm going to go to Structures, Dams, Draw a Dam. I'm going to draw the center line. I'm going to pick a crest elevation of 115 meters. I'll just recreate my template here. And I hit OK. I'm going to select my grid, and the elevation guide here is going to pop up, and it's going to tell me what is above and below that 115 meters in elevation, which is the crest elevation I entered. So you can see everything in red here is below 115 meters, and everything non-highlighted is above. So this area here is above 115 meters. So I'm going to start by placing my dam in this area. So I'm going to start by placing a point inside this piece here. So click once here. And extend this out. You can kind of see the makings of my dam shell if I zoom in. Put a point here. I'm going to put a point here, here, here. I'm going to put another point here to seal it against that topography, even though we can't see it. And then because in the future, this dam might very well go above this piece of topography, so I do want to close this dam, I'm going to hit C to finish it off so that it's closed. Then spacebar when I'm done. Okay, so I did create. I turn off the visibility of my grid. I can see here I created, a dam shell, but really I'm just looking for this center line that I want to use for my template. This is really what I need, is this red line here. So I'm just going to unload the dam shell. I don't need it. I don't need the break lines right now, but I'm going to save this for later. And I'm going to save my dam center line. And unload both the dam center line and the break lines now that they're saved. And open that grid back up again. And hit P to go back to plan view mode. Okay, so I have a generic dam design that I've defined as a template. Now I'm going to apply it to that specific center line that I just created. So I'm going to go to Dam Templates, Setup, Dam Template Manager. So we started in Dam Profile Manager. Now we're going to Dam Template Manager, the second one here. I'm doing a single profile dam, and I'm going to right-click on that and go New again. I'm going to call this CL. I called my template that, so I don't want to get it too confusing. So I'll call it CL_1 just to differentiate it. And now it's asking me for a reference line. So this is a line that the software can use to apply that predefined design to build up dam shells. So because we have a centerline dam, and the center line of a centerline dam is never going to change in X and Y, at least theoretically, right? It's just going to move up and down. So we can use that line that we created, that center line that we created, and then just apply that design to it and create new dam shells up and down at different elevations. If this was, and we'll take a look at this after, if this was an upstream dam, what wouldn't change is that downstream toe. So we would use a downstream toe as our reference line, because we could always just project up from that downstream toe at the downstream slope, go across at the crest width, and then go down at the upstream slope, and do that for different elevations. So in this case, centerline dam, you're using a center line as our reference line. Upstream dam, we would use a downstream toe, and a downstream dam, we would use the upstream toe. Okay, so I'm going to hit that, and I'm going to go find that dam center line we just created. It's asking me which profile I want to use, which template I want to use. We only have one, the one we just created. I'm going to select that one. And this is a closed dam. So I will check that off, and then I'll hit OK. I'm going to save it. And then let's run it. Okay, I'm going to go back to dam templates, dams, raise dam. It's asking me once again, what profile do you want to use? Because you might have many. I'm going to use that one I just created. That's CL1. So that CL1 is referencing that center line we drew and has that 4:1, 3:1, 50-meter wide crest design. And it's asking me what target elevation do I want to use? So what crest height do you want? Well, even though we created it at 115 meters in elevation, here I just want to go up to 125 now. What base grid do I want to use? The one I'm looking at, grid 10. I want to build it on grid 10. I don't have any cell boundaries yet. I do want to save the results. Okay, a benefit of using dam templates, especially as we get into automation, which we'll probably cover in future sessions, is in this advanced tab. Okay, you have the option to generate to create a discharge line as you create the dam shells, as you create the dam structures that you're going to merge into your topography. Once I click this, it's going to create a discharge line for my dam at a distance from my crest that I get to set and at a point spacing that you also get to set. So right now, it's asking me height below dam crest for discharge points, 1 meter. So it's going to create a discharge line 1 meter below my dam crest, depending on whatever dam crest elevation I put in. So right now, it will create that discharge line at 124. If I made that 135, it would be 134. And it's going to put a discharge point every 150 meters. You can change that as well. I'll just leave these as 1 and 150, and I'll hit OK. There you can see it. When we created that shell at 115 meters, this portion of the dam was below topography. Now that we're at 125, it's above topography, so it's all visible. And if you look here, it's created a bunch of new layers. Okay, so I'm going to toggle the visibility of grid 10 off, and then just kind of run through these layers one by one. Okay, so it's created break lines of that dam shell. It's created the shell itself, unclipped. It's going down 100 meters from that dam crest, the skirt height that we set. Beyond that, it's creating a merge grid. So it takes that unclipped shell, takes the original topography, and merges it together. So you don't have to do that. It creates a footprint. So this is where, your new dam exists, where that unclipped shell intersects topography. And it also creates a dam discharge line. So here you have a discharge line, discharge point every 150 meters. You can see that it's not a normal polyline because there's 150 meter spacing on the points. So sometimes these corners, there's no discharge point there, so it kind of gets rounded. Everything is saved automatically because if I go back, we selected that option. So it saves everything, and it saves everything into a folder or a subfolder that's going to be created in your working directory with your dam template name. So our dam template in this case was CL_1. That's the 4:1, 50, 3:1 design that we're linking to this center line. So it's always going to create a subfolder in your working directory and you're going to save all those newly created layers in that subfolder. Okay, so we raised it through an elevation. We can raise it, however, through a volume. You'll also notice in your output window, another benefit here is that it's giving you the fill volume required to build this up to 125. So we can see this is a 1.45 million cubic meter fill structure, and we get the footprint area, which corresponds to this line here of about 1.1 million square meters. Okay, so I'm going to unload everything except my grid 10, my original base grid. Let's do that again, but raise it by volume. Dam templates, dams, raise dam by volume. So once again, I'm going to use that one template, the one that exists. I'm going to pick my grid 10 as my base grid to work off of. Initial elevation, that's kind of your guess as to where that dam structure is going to end up based on the volume you're going to enter later. I'm just going to put 125. In my target volume, well, I know 125 meters for this structure is about 11.5 million cubes. So I'm going to make this 15 million cubes. I think that's 15 million. I'm saying, could you get the structure to within 1% of my guess? 0.01. You can change this to whatever you'd like. Just don't make it absolute zero, or, it needs to find an exact answer, and it probably won't get there. It won't work. Max elevation change. This is just defining how it's stepping through different iterations to get to that structure. And there's no upstream toe extension, and I don't have cell boundaries again. Once again, I have the option to generate a discharge line automatically at a distance that I defined below the crest and at a spacing that I also defined. You can hit OK. You can see here in your output window, it went through a couple of iterations to get there, namely 3. Well, I guess 4 if you count trial 0. So it started at 125. I was like, okay, no, I have material left over. Then I went to 130 because you defined it in 5, step through in 5-meter increments. And then, okay, well, our results are going to be between 125 and 130. Let's try 127.5. And then finally got to 128.172. And then that was the appropriate guess given the error tolerance that we set. So if you wanted a roughly 15 million cubic meter fill dam structure, if that's how much material you had available to you, you could build that crest elevation up to 128.172. So depending, on what information you have, are you building to a specific elevation, you can just use the raise dam function. If you have an amount of volume that you're trying to place, you can use the raise dam by volume function. Once again, and maybe there's something to be careful of, because I had the same base working directory, and I've defaulted this to save automatically every time, it created a new CL1 folder and repopulated all those layers. So it saved over what I had before. So that's something to remember. It's going to save automatically, and it's going to name it the same way, and it's not going to ask you if you want to overwrite these files. It's just going to save it. So if you're going through different scenarios, you want to keep old structures that you built, maybe move your working directory around or create new subfolders before you run the template again. Okay, so I'm going to do this again, but this time I'm going to create a couple cells. One on the left, one to the west, one to the east, and then you can see we can raise each cell separately. Also, I should note, if you're ever curious about information on the software, and you don't necessarily want to attend these or watch videos all the time, The help menu is actually really good, especially help contents, command reference. And this is organized like your menus here. So right now I'm in the damn templates folder, exploring the damn templates. So I'm going to go to damn templates here. And you can see there's, um, it's organized even as the subfolder is organized. So damn templates, dams. I want to look into raise cells next. Well, this has all been written up to really let you know how that works. Gives you visuals, examples of how it works, even how you should fill out the different menus. So a lot of the stuff we cover, a lot of the answers you might want while using the software, you can find a lot of that stuff in the help menu. Probably mostly everything, especially if it's fairly straightforward functionality. Once again, if you want to look into different deposition types for depositing tailings, go to the ooze menu, multi-stream deposition, which we'll take a look at later. And, you can just take a look at the different deposition types. There's a lot of information here, a lot of information. Okay, so I want to create two cells, one to the west, one to the east. So I'm just going to draw a couple polygons here. I'm going to go to polyline, create, draw a line. I'm going to call this cells. I'll opt to show the guide. But mostly what I want is I just want these cells to be visible as I draw them in plan view. The best way to do that is just to make it at a high elevation so I can see it. So I'm going to go 200, which I know is well above the topography here. I'm going to hit OK. And I'm going to draw a polygon at 200 meters in elevation. And we're going to take a look at some polyline draw tools here. Okay, so this is going to be my first cell, just defining the west area. Just digitize some points, and I want this to be closed, so at the end I hit C. Yeah, I want to keep drawing lines. I don't want to, um, you know, stop adding line work to this layer. So hit N. And now I can continue to draw lines and add it to that layer, as opposed to maybe drawing multiple layers, merging them together or whatever. Okay, also, I want this to be two cells that are, sealed together. I don't want any gaps. I don't want to approximate where it is. So I really want the other cell to start at this point, to end at this point. So there's no overlap. So right now, if I look at my draw options, I'm in fixed elevation mode. So no matter where I digitize a point, it's going to be at 200 meters in elevation. And that's good. That's what I want. I want it to be visible. But I want to seal these. So to start, I'm going to go here and I'm going to snap to point. Now snapping to point allows me to start right here for my next polygon. Okay, but now there are no more points to snap to. I'm floating above topography. If I wanted to, I could snap to the surface. You can also snap to a line. You can create a gradient. But I'm going to go back to fixed elevation mode just to make sure everything's at 200 meters in elevation. I'm going to continue drawing this cell. I'm going to finish off by snapping to a point again. And then to close my polygon correctly, I'm going to hit C. And then hit spacebar because I'm done. I have my two polygons. One to the west, one to the east. You can see here, all at a consistent elevation. And I'm going to save my layer. Let's close everything down except my cells and my grid 10, my base grid. Now let's raise it by cell. Dam templates, dams, raise cells. Okay, I'm going to pick my grid 10. My cell boundary is that cells line work I just created. Once I load those cells, it will load up the individual lines within that layer. So there's two, line ID 0 and line ID 1. And they are listed in the order that they were created. So 0's to the west, 1 is to the east. I can switch those. We'll show you how in a second. Okay, so this just allows you to raise the dam using that template to different elevations versus raising it all to one elevation. So on this side, I want to go to 125. And on this side, I want to go to 135. And yeah, let's create some discharge lines again. Hit OK. Let it go to work. Let's take a look at this. I'm going to turn my cell layer off, my grid 10. And take a look at this new merge grid that's been created. Okay, so you can see here, I've applied the template. You can see it's the center line template, same center line, but different upstream and downstream toes depending on the elevation that we're at. And one side's here at 125 and the other side's at 135. Now it's not feathering or transitioning from one side to the next. It is kind of a vertical drop here. So probably not how you'd build it in real life, but if you're trying to get volumes, if you're trying to design something quickly, especially if you want to, string this together with a lot of other functionality, really quick way to raise dams that contain different cells. You'll notice here in the output window, it's breaking down that fill volume by cell as well. You can see on the left side here, to get to 125, 3 million cubes of fill. This is the footprint area. On the right side or the east, at 135 meters in elevation, 15.8 million cubes of fill. In total, 18.8. As well, in that CL1 subfolder that's been created as a subfolder in your working directory, you now have, the final grid plus dam merged layer. You have the final footprint, but you also have subfolders created for each cell. So you can see here in cell 0, there's a grid plus dam folder as well that contains, only the piece to the west merged in. And this one contains both. So it did this one first, and then it did this one. And it creates those other files, the break lines, the footprint, all that stuff. Also, the raise results are also found in a CSV. So what's been, published in your output window is also in a CSV because people want to work in Excel. So, it's only two rows here, but let's say you had like 20 different cells that you're raising to different elevations. Might be nice to have it all preloaded in Excel here for you so you don't have to do that data entry. Okay. You wanna reorganize, what's polyline 0, what's polyline 1 in your cell layer. You can go here to your polyline options and go to reorder lines in polyline. And then just select that polyline and it'll flip them. Okay, let's do it again. This time we're going to raise cells, but we're going to raise it by volume. Dam templates, dams, raise cells by volume. We're going to take grid 10. We're going to use that cells line work. Let's say we're targeting 130 meters in elevation, and we have 20 million cubes. Hit OK. Let it go to work. Okay, so it raised the individual cells. Try to utilize all of that 20 million cubes. So utilize 17.214 million. So it had 2.7 million cubes left over, and it achieved 130 million cubes in elevation. So because I had an excess here, it raised everything to 130. Okay, so what if I don't have an excess? Let's do that again. Okay, so I just right-clicked, recent commands popped up. I'm going to run that raise cell by volume again. Right-click on a cell. I want last value for all fields. I'm still going to use grid 10. I'm still going to use that cells outline. Okay, so this time I want to go to 130 again. I know now it's going to take 17.2 million cubes. Okay, so what happens if instead of 20 million cubes, I put in 15? So you can see here, it built up one side, the west side, to 130. And then with the volume left over, it put that into the eastern cell. But we didn't have enough overall volume to get to 130. So the eastern cell here is at 121. So in this case, because we have a deficit, it builds the first one first, the first cell first. And then with whatever's left over, it moves it to that second cell, but we fell short. As opposed to with the other example where we had more than enough volume to get to 130 meters throughout, it let us know, okay, you only need 17.2, you have 2.8 million cubes left over. Okay. Okay, more dam template features. I want to create a volume elevation curve for dam shells. So dams, create volume elevation curve for dam shell. All right, so based on this template that I'm using, the same one that we've been using for a while now, 4:1, 50 meters across, 3:1 down, at that reference line location, center line dam. Let me know, okay, from 115 meters in crest elevation to 135 meters in elevation in 10-meter increments, what's my fill volume going to be? And I should have had a grid loaded up before I ran it. Okay, load up your base grid, right click, run that recent command again. Last value for all fields. So 115 to 135 in 10-meter increments. Maybe I'll do 5 since 10's fine. Hit OK. Select my grid. And I can see here it's created the fill elevation curve. So I'm going to just click that. It's going to copy those values. Then I'm going to go to Excel here, paste those in. And you can see here, okay, for 115 meters in elevation, you need 3.5 million cubes. For 125, you need 11.44 million. For 135, you need 24.14. And these would be cumulative. A base grid that you're working off of to 135, base grid to 125, base grid to 115. So you want to get a lot of volumes quickly. This could be a good way, and you can make this as segmented as you like in terms of iterations. I'm going to clear my graphics. I'm going to load up grid plus dam. Okay, so a bit of a strange looking structure here, especially since, I have differing capacity on both sides. But let's say you want to make a fill or a storage elevation curve for a dam structure, namely this one. Okay, I know here this is built to about 121, but let's say I'm not sure. First thing I want to do is I want to find the maximum containment elevation. I'm pretty sure we covered this last time, but very useful tool. I'm going to go to surface water, info, find maximum containment elevation. I'm going to select my grid, and then I'm going to pick a point where the pond would exist. This is going to give me some information and generate a new layer or a couple new layers. Okay, so it's letting me know here my maximum containment elevation is 121.021. So that is the crest elevation it achieved. Not exactly 121, a little above that. So I could fill this to 121.021 and then it's going to fail. It's creating this max pond. So this is a pond at exactly 121.021. And it's letting me know the surface area of that pond and the amount of volume there. So it can still hold 30 million cubes, 30 million cubes plus. The new layers it's created. Okay, it's created that max pond inside that dam structure, the outline of that pond, and also the first open contour. Just letting you know when it fails, it's going to fail like right here. And that's where the water is going to go. Okay, so 121.021, let's say it's 121. I want to build a storage elevation curve here. I'm going to go to grid, volumes, grid, volumes, create basin peels. It's asking me what's your maximum storage elevation? What kind of it, where do you want to run this tool? Okay, so it's going to start at your topography within your TSF, and it's going to go up to an elevation that you specify. I want to go up to 121. You can do it in whatever intervals you'd like. Just for, speed's sake, I'm going to go 10-meter intervals, and I'm going to call it basin. It's going to ask me once again to pick a point in the TSF. So I'll pick a point right there. Or sorry, I was asking me to select my grid. I selected the grid with the dam merged in. Now it's asking me to pick a point inside my TSF or dam. And then it's going to create the CSV file in your base working directory. Open that up. You can see here in 10-meter increments, it's created the information you need to do a fill or a storage elevation curve. Volume in that 10-meter slice that you can store. It has the volume per slice, the cumulative volume, and then also the 2D area per slice and the 3D area per slice. 3D area, liner area, because that's the area you would need to put a liner down. Okay. Let's move on. One thing before we move on, though, I'd like to I guess show you guys, it's kind of a cool feature. When you run that tool, it also creates this internal pond surface layer, which is, the storage area within your dam. There could be some uses for this. Maybe you want to, present things differently, contour just the internal basin, have it be a different color, work with it. So that's created automatically when you run that tool, which is kind of cool. Okay, let's talk about surface water tools. So my base folder is getting a little busy here. So I'm going to create a new directory and call it surface water. Then I'll just start, putting my new files there. I'm going to open up my grid 10 again, though. Okay, so the surface water tools are really good if you're looking to figure out a catchment area or where your stream networks might be, because you want to estimate, a volume of water that's going to come into a certain area from precipitation, for example. Okay, the first thing we need to do, though, is we need to take this grid and turn it into what we call a flow grid, which is a grid that allows us to determine where the stream networks are, and therefore, from there, get those catchment areas. So just load up your topographic grid, go to surface water, watershed, and then run that watershed wizard. Select your grid. It's asking me to select any internal basins or ponds, then press space when I'm done. I'm just going to say there's no internal basin, no ponds. Then we hit space. Then it's going to process. Now, depending on the size of your grid, this could take a bit. I have a 10-meter grid spacing, so this might take a couple minutes. Hopefully, it'll be pretty fast. But you can see here right now, it is filling depressions in the input grid. So it is modifying the grid, our base grid that we created that we're using. So this is going to be, it's going to create specifically a flow grid. And the flow grid should only be used to determine stream network catchment areas. You shouldn't do design work, run volumes on your flow grid, because, it has modified it a little. It is going to fill depressions, and kind of, partially hydro reinforce it in certain ways, so that you can, determine how surface water would flow on that topography. You can see here it's letting me know how many points are remaining for it to process. Uh, Not always a linear process in terms of the points remaining. Hopefully it's done pretty quickly. This is giving you an idea, though, for this 300,000 point topographic surface. If I'm processing it into a flow grid, how much time it's going to take. Okay, it's finalizing now. If you ever feel like you want to stop, maybe you're caught into a process that is too long in terms of creating the flow grid, there is this X button here that you can click to, cease the operation. Almost there. We'll edit this out of the recording. Okay, it's done. Right, so it's created 3 new layers here. I'll just toggle the visibility of my grid 10 off, and you'll see the grid is still visible here because it's created this flow grid. So it's that processed grid 10, it's filled depressions, has modified it, but it looks almost identical. And structurally, it's probably very, very, very close. There's probably very little uh, differences in volumes here, but still differences. Okay, it's created streams, in this case, just one stream, and sinks. Okay, so let's take a look at the streams and the information on that in the output window. Okay, so what it does is it, by default, is going to create the stream network, and it's going to create the streams that are fed by whatever 10% of the surface area of your overall grid is. Okay, so in this case, this particular stream is being fed by 2.992 million square meters. Right, so this overall is 29 million square meters roughly of topographic grid. And this stream here is getting fed by 10% of that. So really, what this is telling you is this is the major stream here for this topographic surface grid. You know, this is the main one, and it's getting fed by almost 3 million square meters. Okay, well, I want a little more detail here in terms of my streams. I don't want just this one. So I'm going to regenerate my stream network. First, I'm going to save my flow grid, and I'm going to save it to my surface water working folder. Okay, just as a test here, I'm going to make imagery my working directory, and I'm going to try to run a surface water tool. I'm going to say, okay, could you please regenerate the stream network? But instead of doing streams that are fed by almost 3 million square meters, let's bring that down a lot and generate all the streams that are fed by 50,000 square meters. So generate more smaller streams. I don't need just like the major ones. I'm gonna hit OK. It's not gonna let me work. It's not gonna let me do it because there is no flow network in the directory that I'm in. So if you want to use a surface water tools, make sure your working directory has the flow grid in it. Let's try that again. Right click, regenerate stream network. Let's go with 50,000 square meters again. I'm going to call this streams again. So it's going to overwrite this existing stream layer, which is unsaved. I'm going to select my flow grid. I'm going to overwrite that existing stream layer because I called it the same thing. So you can see here, when you lower that contributing flow area from 3 million to 50,000, it creates a lot more streams. So, you can, not exactly sure, what number you'd want to choose if you were, studying a particular facility, but you can play around with it to get a specific area or a specific density of streams. Okay, so streams are nice, but this particular case, what does this mean to me? Well, what we can do now is for particular streams, we can visualize the catchment area and quantify that catchment area. Okay, so I'm going to go to surface water, watershed, generate catchment area. Okay, call it catchment outline. Once again, I'm going to select my flow grid, and I'm going to select a random point. Okay, well, I selected a random point, but the issue here is it's outside my stream network. So I generated a lot of different streams. So I've really mapped the path water is going to take. I picked a point outside of that. So you can see here, really water is not going to accumulate or flow through here. It's telling me, if I take a look at the new layers that has been created, this is a very small catchment area. Really water is not going to accumulate here. And the catchment area in this case is 425 square meters. Okay, so let's run this again, but this time, pick a stream, an active stream, and maybe a fairly major one over here. Right click, generate catchment. I'll overwrite these existing ones. I'm going to select my flow grid. And then I'm going to pick a point where I think water is probably flowing pretty well right there on that stream. Okay, so much different situation here. If I turn off the visibility of my flow grid. Okay, so I can see at this specific point here, really large catchment area. So water is really accumulating to that point. I got, a 13.962 million plan view catchment area, a little larger in 3D, the membrane area. So 2D area, plan view, 3D area, membrane. So about 13.9 million, almost 14 million square meters. And it's pretty much this entire area. So any precipitation here in all of this area will end up flowing to this point. Maybe we can visualize that with making a quick elevation style. So I'm going to go to my style manager. I'm going to go to the elevation shader. I'm going to create a new one. We call this elevation. I'm going to swap my hue start and hue end. So I go high elevations, warm colors, low elevations, cold colors. I'm going to make this, I think 256 is the max in terms of the number of increments. I'm going to hit OK. I'm going to hit OK. I'm going to apply that new style that I made to the catchment area just to visualize it. So, the elevation shader is letting me know, yes, this is the lowest point there. So everything would flow here. And you can see that in the topography as well. There's obviously some sort of depression here in the topography, but everything's just going to accumulate here and flow to that point. All right. Just going to save my streams and close down my catchment outline, close down my surface area, and unload my sinks layer as well, which I'm not going to use. All right, let's take a look at some dynamic modeling tools. And once again, I'm going to create a new subfolder. And first I'm going to clear my graphics and just unload these layers. New directory, call it dynamic modeling. Hit OK. And go back to my base folder, load up grid 10 again. But I kind of want to start exiting this folder entirely. So I'm just going to take this grid 10 here and copy it to the working directory. So it's going to create a copy of this, put it in the working directory, and then I don't really have to, kind of bother with this base folder, which has become quite messy. All right, for reference, I'm gonna open up my streams again. I'm gonna apply that elevation style to my overall topographic surface. And I'm gonna take a look at, maybe creating a ditch, creating a sump, maybe rerouting one of these streams to that sump with my ditch and an excavation or sump network here. Just something, quick, but um, fairly accurate. Okay, so let's say this stream here, this is a problem to me. I want to reroute this. And based on how the topography looks, I can tell everything's draining this way, to the northeast. So I'm gonna set up a, sump like right here. And then I'm gonna try to reroute the water, intercept it with a ditch, and put it into that sump. Okay, so under the structures tools, we covered a few last time. Today we're gonna cover excavations, ditches, briefly dynamic ponds, and then dynamic roads. Okay, so let's take a look at excavations. 4 different ways to make an excavation. Let's start with drawing an excavation. Okay, first is you enter the base. What's the base of the excavation? What elevation do you want? Okay, so I'm looking at the range of elevations here on my topographic surface, highlighted by this histogram here. Okay, so, I'm going to put this down to 75 meters. Overall, I'm going to cut down at 2:1. And it's going to be benched. Bench height's going to be 10. Bench width is going to be 10. And overall, I'm going to go down 50 meters in terms of the shell height. But the base is going to be at 75 meters in elevation. I'm going to select this grid. And I'll draw my excavation just on the screen. Put it here. There. There, I'll add maybe a little corner to it. Then I'm done. I'm just going to hit spacebar. Okay. So it's creating new layers. It's going to untoggle the visibility of my original grid 10 and take a look at the new layers I've created. Okay, one, it created the line I just drew. The unclipped shell. Now that unclipped shell merged with the excavation. So we picked a shell height of 50 meters. So what it did was it started at that base elevation that we entered, 75, and then projected up 50 meters to 125 meters in elevation and created that unclipped shell, and then merged that shell into the excavation. So this is a dynamic model. So I can change input parameters here, and it's going to change the excavation volume, the footprint area. So I want to go down to 50 meters. You can see it's expanded the excavation. I'm still within that. It's modified my crest line. And now the base is at 50. You could, change the shell height instead of the base elevation. You can change the bench width, the bench height. You can see here it's changing the configuration of your excavation and also updating your excavation volumes. I'll put that back to 10. I kind of like the look of it. And it seemed a little more substantial when I went a little lower. So I'll try 60 here. Okay, so that's how you would draw an excavation. Okay, so let's check out the other ones here. I can just continue to use this grid. Say I want to put an excavation down here. Structures, excavation, bench excavation from crest. Okay, so let's create a crest line and use that. So polyline, create, draw a line. I'm just going to float this above my topographic surface. So I'm going to make it at 200 meters in elevation. Just going to put it right here. Just a rectangle. Okay, so right now, my crest is, well above my surface. What the software is going to do is it's going to start at this line, at this elevation, and then it's going to project down and try to create that excavation shell. So, if I am excavating, I am starting the digging process at the surface level. So I want my crest to be near my surface or on it. So I'm going to just take this and drape it onto my surface. Polyline, drape. I have two options, essentially. Drape points on surface or drape line on surface. I believe we covered this last time, but differences here in the two functions. Drapes point on surface, it will take the points that I digitized when I drew the line. It will take those points and it will stick those on the surface. So right now I have a rectangle made up of 4 points that I drew. It will take that and it will drape 4 points onto the surface, and the resulting layer will still have 4 points. If I drape the line on surface, it is going to densify this line with many, many points. It's going to take the polyline as it exists. It will drape that onto the grid. Every time that line intersects the grid, it will add a new node, and I'll go from a polygon with 4 points to a polygon with, thousands. And you don't really want to work with line work that has tons of points. It's not good computationally. It's going to slow things down. It's going to create really unsmooth and jagged looking surfaces if you try to triangulate it. So I'm going to elect to drape points on surface. You don't have to do this, but I want my crest to be visible to me in plan view. So I'm going to float it off the ground by a meter. So I'm going to add a vertical offset of 1 meter. Select my surface. Select my line, and then I can see here I'm just floating above ground. Okay, go back to my structures, excavation, bench excavation from crest. Once again, I'm going to pick a base of, well, let's check quickly where I'm at here. I'm at a 111, 112. I'm going to go down to 100, 2 to 1, 10, 10. Merge it into the grid. I can create a dynamic model again. Hit OK. Select my line. Select my grid. You can see here it's creating a new merge grid with that excavation built in. And so now in my dynamic models property window, I have multiple dynamic models, multiple dynamic excavations here loaded up, and I can play around with these features. So I have excavation 0 over here, and then excavation 1 down here. And I can, and you can see here, this is a 17.6 million cubic meter excavation, so pretty substantial. So you want to, size this for capacity quickly. You can just add a dynamic pond to this. So when you go to dynamic models, ponds, I can add a dynamic pond by elevation. You can also do it by volume. I'll call it pond. I'm going to connect it to this merge grid here with these excavations built in. I'm going to put a point in the pond. You can see here, I have a point that I've selected. It's created a pond. The pond is at 65 meters in elevation, and that results in 292,000 cubic meters of storage capacity. I want to change that, so it's 90. Well, you can see it'll regenerate that pond surface, and then let me know now I have 7.2 million cubic meters of storage capacity. Otherwise, I can change the base elevation of my, or the base elevation of my excavation, and that'll give me more storage capacity. So right now I have 7.2 million, given this 90-meter pond elevation. I'm going to come here. I'm going to change the base elevation here from 63.9 to, let's say, 50. And now my pond volume's gone to 13.4 million from 7 million. So I want to size an excavation structure quickly in terms of the relationship between excavation volume and storage volume. You can do that with a dynamic pond model and a dynamic excavation model. Okay, let's talk about ditching. I guess quickly, that's a benched excavation. You don't have to make it benched. You can just do the excavation from crest. It'll just excavate at a consistent slope, won't put any benching in. Or you could just do an excavation shell from the toe itself. So instead of using the crest, you use the toe, and then it would project up. Okay, different ditching options. We're going to run out of time here, so I'm going to go a little more quickly. And I'm just going to create a ditch from the center line. And I'm going to utilize the line profile tool this time. Okay, so I have a stream here. Let's say I want to cut this off right here. And I want to build, a ditch. I'm just going to cut it off right here. Kind of take a 90-degree turn and guide that water towards my excavation over here. Okay, so I'm going to start by building a center line. So I'm just going to draw a line, create, draw a line. Once again, I'm gonna float it above the topography again, and then drape it, and then modify it. I'm gonna put this up at 200 meters in elevation. I'll show the guide, but I know everything's gonna be below that. Okay, so I'm just gonna cut the water off here, go through here, take a turn there, and I'm just gonna guide the water into the edge of the sump. Okay, so that's my line. Okay, now I'm going to drape this onto the surface. Polyline. Drape. Drip points on surface. Like my grid. Turn off some layers. We got a lot of layers going on. Okay, so I have a center line, in theory, of where I'd like to put my ditch, and I have my merge grid with my excavation built in. Okay, so I'm just going to make sure that this is sloping properly so that I have enough gradient to make it to my sump. Okay, so I'm just going to go to Polyline, Edit Long Section Profile. And I'm going to select my line. And I'm going to select my grid. New menu is going to pop up here. And this is displaying a polyline and the topographic surface. I'll change the vertical exaggeration so things are a little more visible. We'll go from 3 to 1 to 10 to 1. Okay. So here is the start of my ditch. And here's my sump. So I do have a bit of an issue in terms of locating my ditch. It's draining the wrong way. All right, so I'm going to select these points. Select them all. I'm going to set the grade. So going from this point here, the start of my ditch, to the end of my ditch, I want this going down at at least 0.5%. All right. Going to update that 3D alignment. Close this down. Then I'm going to generate my ditch from that center line. Structures, ditches, create ditch from center line. I'll go 10-meter base, 2-to-1, 2-to-1 in terms of the cut angles. I'll call that ditch, then I'll merge it into the grid. Hit OK. Select my center line here. That's just barely visible in this area. Select my base grid. Close down some layers. And attempt to find my merge grid in the many layers that I've created. And, probably should have managed these a little more properly. Take my ditch shell. Take my merge grid. And I'm going to merge my excavation into my grid. I'm going to go to grid, merge excavation into grid, select my grid, select my excavation, ditch, Interesting. Okay, well, you can see here the excavation shell. It doesn't seem to be merging it right now, probably because I have too many layers open, but you get the idea. You can update things in that edit line profile tool to kind of create the center line that you want. Okay, let's say another example here is you want to create a road structure. You want to balance the cut fill quickly of that road structure. So once again, I'm going to start with a center line, create a grid model or a dynamic model, and then use that edit line profile tool to make changes of that center line dynamically as it updates the 3D model. I'm going to close all this down though, because I have too many layers open and it's making things a little harder to load. So I'm going to unload this, and I'm just going to work from my base grid 10 again. Okay, so I'm going to draw a center line here. It's going to float it above the ground by 5 meters. So once again, same process, polyline, draw a line, put it at 200. Semi-road starting here. It's coming like this. I'm going high to low. Let's say I just run it till there. Pretty simple configuration. Polyline, drape points on surface. I'm going to float this 5 meters above topography. So in areas of fill, maybe I'll have about 5 meters of fill. Select my surface, select my polyline. Okay, so my line, you can't really see the 5 meters in distance, but it's floating above the road. I'm going to clear my dynamic model window just so only the new model pops up. Okay, now I'm going to create a dynamic road model from the center line. So dynamic models, structures, add dynamic road from center line, merge it into the grid. I select my line, select my base grid. You can see here it's created some new layers. Cut shelf of the road, fill shell of the road. Don't really need those. and it's created, a road structure 5 meters above my topography throughout. It's also created that merge grid with the road built in. Okay, so right now, this road is 242,000 cubes of fill. No cut, because I'm floating above the road in all cases. I draped it 5 meters above. So 0 cubic meters of cut, 242,000 cubes of fill. And you can see the footprint area here. And you can change these parameters. If I want to do 3-to-1 fill slope as opposed to 2-to-1, you can see it increases the fill. I want to change this to a 25-meter wide road. Once again, change the input parameters. We'll change the outputs. Okay, I want to balance this road though. I don't want just fill. I want this to be as close to 0 as possible so I could just go cut to fill and not have to import dirt or, get rid of it at the end of the project. Right, so quick way to do that. Just going to make my center line visible, my original surface, not the merged one. I'm going to go to polyline, edit long section profile again. I'm going to select my line. I'm going to select that base surface. That's going to bring this back up. Before I get to work though, I'm going to close down that base surface and reopen the merge grid. The reason I'm reopening the merge grid is, as I do modifications to the center line, if I want those modifications to be transferred to the design, to be transferred to that merge grid, it needs to be open or visible in your 3D window. Okay, so I have my original ground surface here and my center line. I'll once again increase this vertical exaggeration to make things a little visible. You can see here I'm just floating 5 meters above my original ground surface. Okay, so I want to balance this out. Let's make some quick changes. I'm going to add a couple points here, to my center line, just so I can make changes in different segments. Okay, so right now I'm about 500,000 cubes of fill. Let's say I want to cut in the beginning and then fill on the back end. So I'm just going to take this and select these points. I say go down at 1%. All right, that looks a little heavy. I'm going to update my 3D alignment. All right, so now I've really changed the balance. I have about 550,000 cubes of cut, 130,000 cubes of fill. That's not going to work. Let's just move this up. Move this up. Let's see if we can get that a little closer to balanced. All right, we could probably play with this a little more, but we're pretty good now. 160,000 cubes of cut, 143,000 cubes of fill. So now instead of being purely fill or purely cut or, an unbalanced road, it's getting pretty close to 0. So with a couple more modifications, you can get this to be completely balanced and at least visualize a configuration of a road where the cut and fill would offset. So just a handy tool to make modifications quickly, change the alignments, add points, and see how that affects your volumes. All right, let's get into some multi-stream deposition. I'm going to go over time here. I apologize, but hopefully you guys can stick with me. If you need to go or you miss anything, I will put this up as a recording, probably today or tomorrow, that you can download and watch at your discretion. Okay, let's unload these. Open up my grid again, and do some multi-stream deposition in this little valley area. Okay, so just gonna draw a dam here. You can see, there's a little valley area that we could place some tailings, but we need to dam it off. I'm gonna go structures, dams, draw a dam. Just gonna call it dam. I'm gonna put this up to 127 meters in elevation, 20-meter crest width. 3-to-1, 3-to-1, 50-meter shell height. and I'm going to make a dynamic model. Let's select my base grid, and then just draw a dam right here. Okay, so I've dammed that off. Just going to take a look at my merge grid here. And once again, I have another dynamic model loaded here for my grid at that 127 meter elevation. Now I'm suspecting this is a little overbuilt, just looking at it, you know? Do I really need that big of a structure? It's going to be 468,000 cubes. I look like I'm well above topography. Okay, so I built this up to 127, but how much storage capacity elevation-wise do I really have? Once again, I'm going to use that surface water info, find maximum containment elevation tool, select my grid, the merged one with the dam contained, and then pick this point right here. Okay, so it's letting me know, yes, you've built your dam up to 127 over here, but the reality is your maximum containment elevation is 113.736 because that's the elevation at this point right here. So, you know, if this were to fail, or if this, if you went above that elevation of 113.736, this is where the water is going to go, up this way to the southwest. Okay, so I really only need containment up to 114 for my dam. So I'm just going to lower that down to 114 and save, a substantial amount of dirt there. All right, we don't need these max pond layers anymore, so I'm going to unload this. Well, one thing I'm going to note here is the maximum storage volume, 830,000 cubes. So no matter what I do, I really can only store 830,000 cubes in this area, unless I start reinforcing material here and here to, build containment up throughout. Okay, so I'm going to unload this, and I'm going to use this surface now, my merge grid, with my dam built in to pour some tailings. And I'm going to save this merge grid. All right, so a couple things I need to do before pouring tailings. Define some tailings types, define some discharge locations. Okay, let's start with defining tailings types. 𝐓𝐸, project, tailings database. I'm going to create two new tailings types here. I'm going to call this T1. Densities above and below water, I'll keep them at 1. You can make them whatever you like. Slope above water. We covered this last time. There's a multitude of ways of defining slopes. You can do it 1 slope above water, 1 slope below water. You can make compound slopes based on distances from the pour point. You can enter a polynomial equation that will model your tailings slope as a function of the distance from that pour point as a polynomial equation. I'm just going to do linear right now. So I'm going to go above water 0.03, below water 0.05. So that would be 3%, 5% slope. And that's T1. Let's do T2. Do linear again. 0.04 above water. 0.06 below water. 4% above water until you hit the pond. And once you hit the pond, 6% slope. Let's save these and create some discharge lines. Okay, first discharge line, I want it along my dam. My dam crest is at 114. I'm going to put it at 113. I'll just draw it. I could have used a template, would have generated it for me. In this case, I will just draw it. Go to 𝐓𝐸, discharge points, draw regularly spaced discharge points. I'll put it, once again, 113 meters in elevation. I'll keep my point spacing between the discharge points at 100. And I'll opt to not keep drawn points. So this option right here is, do you want to put a discharge points at the locations that you create when you're digitizing the line, or do you just want to space it evenly at 100? I just want to space it evenly at 100. And then I will place a line such that it's close to 113 meters in elevation, which is exactly where this contact area is between the red highlight and my topography, but just slightly below that. So I'm not, creating a discharge line at 113 meters but it's, topography is above it. So just kind of like right here. All right, so I'll just save that. There'll be discharge 1. I'm going to create another discharge location over here. I'm going to draw it again. I'm also going to place it at 113 meters in elevation. I'll do 100-meter point spacing. And I won't keep drawing points. Maybe I will this time. I'll place it right here. I'll call this discharge 2. And let's make a third one over here. But this will just be a single point discharge. All right, so I'm going to hover above here. I'm going to hit C. That's going to copy the coordinates of this exact location into my clipboard. I'm going to go to data import, text data, paste points from clipboard, the point coordinates, which are organized X, Y, Z here in the point order, which you can mess around with if you would like. I'm going to paste those coordinates. I'm going to change this again. We're going to change the elevation of this point to 113. And I'm going to call this discharge 3. One thing to note here, even though it's just a single point discharge, so it's just one point, if you want to use a location to simulate tailings, to discharge tailings, it needs to be saved as a line. So even though technically this is a 1 point, it is a point, save it as a line so that you can load it up and use it in your deposition. And I'm going to save this. Okay, so another thing to note is if you have a line with 1 point in it, it is not visible. So you have to just remember where you put it. Maybe you can create a point file to accompany it if you want to see it visually. But it's not going to be visible in your 3D window. Okay, let's pour some tailings. Ooze, multi-stream, fixed pond volume. So I'm just going to define the pond based on a volume. In my base grid, I want to use this merge grid that I'm looking at with the dam built in. That's the MD0 merge grid. All right, I have 3 different discharge points, so I need a couple more rows here. So I'm going to right click in this gray area. I'm going to add rows. 2 rows. Okay, so now I have 3 different discharge locations. Discharge generator. That's a discharge location. So that's going to be, oh, sorry. Discharge generator is a type of a flow model that you want to use. So really, I think the most practical when you're doing a multi-stream is flow path downslope. So I'll just start the first 2 as flow path downslope. My source is going to be the discharge location. So I'm going to start with discharge location 1, and here I'll put discharge location 2. This will be tailings type 1. This will be tailings type 2. All right, so in multi-stream, and it's different in single stream, but in multi-stream, flow path downslope is really versatile because you can enter a tonnage target or an elevation target. Okay, so for the first location, I just want it to pour to 113 meters in elevation. So that line's at 113 meters in elevation. Just fill tailings up to that elevation. I'm not sure how much that's going to be, but I just basically want to fill it up to the discharge line. So I leave my tonnage at 0, and then I just enter a value for the initial elevation. For location 2, It's different. I want you to place exactly 250,000 cubes. I'm not sure what the elevation is going to be, but I want 250,000 cubes. Okay, for the third one, I'm going to do vertical delta. For single point discharges, I like vertical delta because it has a ton of flexibility in terms of, not being inhibited by the elevation of the point you used. It will use the X and Y of that one point, and it will move up and down. And it won't get hung up by getting, the point being underwater or under your topography. So vertical delta, very flexible. So that'll be discharge 3. I'll do T1 again. And for this one, I'll say just pour 150,000 cubes. For the pond, initial elevation guess, I'm not sure. I'm going to guess 113. It's pretty conservative. And I'm going to do 100,000 cubic meter pond. And my maximum contain, I know from the surface water info function, it's 113.736. I'm going to say 113.7. And I'm just going to run it. Pick a point in my TSF. Just let it go to work. You can see here it is building that configuration with those 3 beaches and that pond volume that works in this area based on those tailing slopes. All right, you can see it here. 100,000 cubic meter pond. Pond elevation ends up being 110.44422. I'll just do a quick post-processing here. First, I'm going to highlight the tailing surface. So I'm just going to highlight the tailings here in yellow. So you can see the poured tailings. I maybe put a contour on that. Ooze. Contour tailing surface. So you can kind of see the evolution of the slope above and below water. Okay, so unload the outlines. So you can see here, pond elevation, pond volume. And it's also giving you, just kind of break this out here. The beach information for all of the discharge locations. So for that first location along the dam here, it poured exactly to 113. Discharge elevation is, the height of the beach at the deposition location. So 113. So it did build the beach up to 113, and then it ended up being 206,000 cubes. For location 2 here, it placed almost exactly 250,000 cubes within the error tolerance, and that ended up being a discharge location of 119.428. So, discharging 250,000 cubes here realistically would result in this discharge line at 113 meters in elevation, if that's where it was, getting buried. So, if this line was really at 113, we need to place less tailings out of this location. You can see the discharge line is here, but the tailings backed up a lot further, buried it because that was just too much volume. For the third location, 151,000 cubes, so almost exactly the 150,000 tons that we input. And the discharge elevation, once again, went above that 113 meter to 115. But because we're using flow path down slope and vertical delta, it's not confined to the elevation that we're entering when we enter a volume target. So it gives you some flexibility in terms of planning. You can see here you have one set discharge location. So you can see how it's placing radially from there. Here, because of the length of the line and the 100-meter spacing, it only created 2 discharge points. So you can see it's discharging from here and discharging from here. Here, once again, Looks like a couple discharge points, one in the north and one in the south. Excuse me. Okay, I'm going to run it one more time. And I'm just going to change the discharge model here to sequential just to kind of visualize the difference. Okay, I'm going to reload everything here. I'm going to clear my graphics though first. Clear graphics, discard everything. Right click, multi-stream fixed pond volume. I'm going to reload everything. I'm just going to change this to sequential. Fixed elevation. And I'm going to note the volume they deposited before is about 208,000. So I'm going to put a tonnage target here. I'm going to say 150,000 cubes. Let's run this again. Pick a point of my TSF and let it go. So the big difference between with sequential versus, as drawn or flow path down slope is that it's going to deposit from one pore location and then from the other, as opposed to doing both simultaneously. So it can change the configuration of your beach. All right, we can see that here. So I knew initially that when I deposited with flow path down slope the first time to 113 meters in elevation, it took 208,000 cubes. This time I deposited tailings from there, but I only deposited 150,000 cubes. So it filled from this location, the first pour point, up to 113 meters. And then the remainder of the volume, the remainder of the 150,000, it deposited from the second location. But we know it takes 208,000 cubes to fill this completely to one elevation. So essentially, I have less volume than I did previously. So it can't place both pour points up to 113. So it places this one to 113, and this one's lower. And we can see here. So this one is like 112.2. So it creates this slanted beach. We'll just take a look at that in cross section. Do a cross section from north to south, include the pond. So you can see it didn't do a uniform beach. It's sloping to the south, and it's creating a pond right here up against your TSF, which you don't want. So that's just one thing I wanted to highlight. Here we can contour the tailing surface quickly. Just take a look at that. So you kind of see how it's sloping down. Okay, well, I think I'll stop there. I went well over time. Thank you for joining me today. We'll continue to put on more of these, record it, post it. Please reach out either to me at sam@muck3d.com. You can reach out on LinkedIn. You can reach out at, info@muck3d.com. And, if you want to cover specific topics, maybe something that's, relevant to your work, let me know. I can try to incorporate that into future sessions. So thank you, everyone, and have a nice day.